Welcome to lesson 7.2. In this lesson, we're going to talk about series. Now, to start us off, let's define what a series is. A series is a list of numbers, aka a sequence, that has been added together. So the sum of numbers in a sequence. That is what a series is. So we're still going to take a sequence of numbers, 1, 3, 5, 7, 9, but now we're adding them all together, and that makes a series. Now, we have two types of series. We have a finite series, which is a sequence that ends, that we're adding together. So like 1, 3, 5, 7, 9. That's finite, and then I can add all those numbers together to get my series. Versus an infinite series is a sequence that never, ever ends with our ... and we're talking about adding that together. So those are the two kinds of series that we've got that we're going to talk about in this lesson. Now, next thing we should talk about is summation notation, how we write this stuff. If I take a list of numbers, so here's my list of numbers, there's my first number, my second number, third, fourth, fifth, on and on till the last number. So this would be like my 1, 3, ... 9 that I'm adding all together. I would write it like this, where this is telling me which sequence term to start on. So maybe, here's my n, here's my a sub n, like we did last class. This is term 1, 2, and we have 3, 4, and this is term 5. So I would go from n equals 1 up to 5, because that's how many terms of the sequence I'm doing, from 1 to 5, from the first term in the sequence to the fifth term in the sequence. That's where that 1 and 5 come from. Then this right here is the equation for the sequence, usually the explicit one. This is the explicit equation for the sequence, which we talked about how to come up with that in our last lesson. So, one other note. If it's an infinite sequence, it'll have a little infinity sign on top up here instead of telling you where to end. That means you're just adding forever and ever and ever. This little symbol here is the Greek capital letter sigma, and it's read as sigma or summation. That's how we say that. So let's try that on example 1. These are all written in summation notation, and we're going to split them apart and actually add them together, because that's what this symbol means. This means sum. So here I'm going to make my table, just like I did last class. But now this is telling me which n numbers I'm focusing on. So I'm going from n equals 2 to n equals 6. And I'm going to take all these numbers and I'm going to plug them into my equation. So 3 times 2 minus 5, 3 times 3 minus 5, and on. Get my answers just like I did in my last lesson. 1, 4, 7, 10, 13. Now, because this is a sum, I'm going to add all these answers together. 1 plus 4 plus 7 plus 10 plus 13 gives me a total answer of 35. And that's how we do this. We're just taking these numbers, plugging them into this equation, and then this means add all those answers up. That's all that means. So I want you to try B. Pause the video, plug everything in from 1, 2, 3, and 4, and then add those all together, and then come up with what that is when you add all these answers together. So pause the video now, try that, and then come back. Let's check your work. I plugged all my n numbers in. I got these fractions, which turn into these decimals. I add all these 4 decimals together to get this. Now, please note, this is not 0.52 repeating because it doesn't go on infinitely. It ends right here. This is where this number ends. So that's why I've ended it after 4 5-2s. It's not an infinite sequence. This is a finite sequence. Okay, last example. N, A sub n. We got 0 to 4 this time. Now, notice this one specifically says k equals 0. That means you're plugging these numbers in for k, not for x. So the x you're actually totally leaving alone. So you should get something like this. I'll do the first one. -1, and then plug in k to the 0 plus 1, over plug in k to the 0 plus 1, times the x stays alone to the 0. Now if I go to simplify this, I would get -1 to the first power over 1, times anything to the 0 power is 1. So this would be -1 times 1 is -1. Versus if I do the second one, plug in 1 to all those k spots, this is going to become -1 squared over 2 times x minus 2, because anything to the first power is itself. -1 squared is a positive 1, so this is 1/2 times x minus 2. So you have 3 more now that you've seen these first 2 examples. I would like you to pause the video, try to plug these 3 in for k, and then remember, because this is a sum, we're going to end by adding all of these answers together into one big long equation is what we're going to end with. So pause the video, try to add those together, and then come back in a sec. Let's check your work. Here's the answers I got for those last 3. Then I added all of them together, and here's where I added all of them together to get one big long equation. And that's my answer. I can't simplify that anymore. It's just a big equation. Now, we've gone one direction where we took something written in summation notation, plugged it all in, and added it. Now we're going to go the other direction. So here in these 3 examples, I have 3 sequences that are being added together, and I want to end by writing it like this. Now, let's talk about these 3 parts again. Remember that these 2 are the terms I'm starting with. So we could call this is a sub n, this is n. This is our first term, second term, third term, and on to whatever this is. So we're going from n equals 1, our first term, and then we'll need to figure out what term number this is, and that will go up there. Now, this inside part is the equation for this sequence. And we learned how to write those equations last class in 7.1, the explicit formula equations that are on your reference sheet. All we need to figure out is if it's arithmetic or geometric. So this one, I'm adding 3 each time. So this is going to be arithmetic. So let's remind ourselves from our reference sheet what the arithmetic explicit formula is. And we know my first term is -5, and I am increasing by adding 3 each time, which means my formula is going to be -5 plus 3 times n minus 1. So that is my formula. That's my equation for this sequence. So it looks like the last thing I need to figure out is what term number is this. Well, if I need to figure out what term number this is, I can set my explicit equation equal to this last term, 22, and solve for n, and that's the term number I'm ending with. So let's solve this. So this is 3, and we get -5 minus 3, which is -8, equals 22 plus 8. So this is actually the 10th term number. So I'm going from n equals 1 up to 10. And that's how we write this sequence. We know we're going from the first term to the 10th term, and here's the equation I get for them. So knowing that, let's look at B. This sequence looks like I'm timesing by a -1/2 each time. So this is going to be a geometric sequence. So let's write out our summation notation. We're always going to go from n equals 1. That's our starting term right here. 1, 2, 3, 4, on and on and on. And it looks like this series is going to infinity. That ... tells me that it's never going to stop. So all I need to come up with is my equation. So let's remember the formula for a geometric explicit formula equation. That's on your reference sheet if you need it. And we know my first term is 5, and I'm timesing by -1/2 each time. So that says that my equation is going to be 5, -1/2 to the n minus 1. And I can write that into here. And that's my answer. So hopefully you're starting to get the hang of this. From whatever we started with to whatever we end with, equation goes in the middle. So now that we've started to figure this out, I would like you to try C. This one is a finite sequence, so that means your tricky part is figuring out what you end with up there. We know we're going to start with 1, 2, 3, 4, but then we have to figure out where we're ending, what term we end on. And then you will probably notice there's some similarities to B, which should help you out with the equation part of it. So pause the video, think on that, and then come back to check your work. Let's look at this one. Now, we need to find out what term number this ends on. You may have started like we did up here by setting the equation equal to that answer to solve for n. However, if you try to do that, you're going to run into a problem. If I set my equation equal to this number and start to solve it, you do have to use logarithms, because this is an exponential form, so we change it to log form. But if you try to type this into your calculator, you're going to get a domain error. And that is because this is negative. So here's kind of the lesson from this. If your r for your equation is positive, you can totally solve this way by changing it into log form, and then you would add 1 to both sides, and that's your answer. If your r is negative, you cannot solve it with the equation. You just have to write it out enough times until you figure out what term number you're ending on. R negative is probably one of the hardest ones to deal with. So since I can't do log form here, I can't solve that, I just wrote my sequence out until I got to the term I wanted and found out that that was term 11, which is what I put there. So that is a basic introduction to series of how we can take summation notation and find an answer, and take a sequence and write the summation notation from it. Or I should say a series, because we're adding them, and write a summation notation from it. In the next video, we're going to dive more deeply into arithmetic series, to be specific. I'll see you there.